Hello, this is Peter Gregory, and this is the solution for the homework that was due for Business 3010 for Friday, 22nd of April. And we're working with standard deviation, z-scores, and this was a working exercise here to get yourself familiar with computing these, knowing what they do, what they look like, and when to use them, what we use them for. Okay. So question one was, what is the equation for standard deviation of a sample? Okay, so we have two different equations, one when you have the total population, and one when you have the sample. And the act of looking it up and writing it down and with your hand, with a pencil, a pen, actually embeds it in your mind, and hopefully you're internalizing this. Okay, so I'm going to get rid of this here, and we use the symbol S for the standard deviation of a sample, where we normally use sigma, a lowercase Greek letter sigma, for the standard deviation of population. Okay. Take every x point that you have in your sample and subtract the sample mean. So you're looking for the distance. How far away is the mean from the sample, or the sample from the mean? And your x's can end up being larger than your average, or they could be less than your average, and that's why we square them. Part of the squaring there gets rid of the minus sign, and we end up taking all the distances, squaring them, adding them all up. That's the top part of this in here. There's really three parts to this. So for every point, first you calculate your x bar, your mean, and then for every point, find the distance of that, put it in a table, square those distances, and then divide by the number in the sample, that's a lowercase n in this equation, minus 1. Okay? So you're dividing by n minus 1. Finally, you take the square root. I'm going to come back to this in a later question. I think it's question 3. Okay. So in question 2, I asked you to put some data into a tank. I gave you some data points here. I'm going to put this together in an Excel file. So we'll go over to a blank Excel file here, and we're going to put in, this is the data entry. Okay, we're recording how much of a substance we're putting into water here to, it's antibiotic for fish. And it looks like we took 7 samples here. Okay, so I'm going to do this on the fly. Okay, and when I take our reading, the value is in grams. So she did this by hand. I wrote these up, and then you're going to calculate these by hand. Okay. So we're going to put in our average, or our mean here. That's going to equal average of these points. And that ends up being 33.32. That works. Okay, so now we're going back to the equation here. What we're doing is filling out this equation. So I left, just like we did in class, I left some spaces on the actual sheet that you have. So we want to calculate all of our x of i's minus x average, okay, what our mean is, okay, for each of these. So for each one of these, we're going to make that equal to the point minus this value, and for Excel we need to make that fixed location, okay, because I'm going to copy this down. Okay, so we had some negative numbers, we have some positive numbers. There's our average, 33.32. We see our first number is 32.91, and obviously it's smaller than the average, so when we subtract the average we get a negative number. Okay, so that's the first part of it. So the next part is to take that and we're going to square it. that gives us a positive number. Okay, those are our next numbers. And then we can get another average here. Well, actually, this is going to be an n minus 1, so I don't want to call it an average, okay? So we're going to sum this up. Sum up those numbers, and we get 0.84, almost 0.85, okay? Now you might get slightly different answers depending on how many decimal places you went out, okay? So then we're going to take care of the inside. So the first part was the numerator over here. We just took care of all this. Now we have to subtract. The second part is subtract by n minus 1, or divide by n minus 1. And that's going to equal this over 7, because we have 7 points. 7 minus 1 is 6. Put that in there, okay? Right. And finally, we take the square root of it. So there's your final answer there. Your standard deviation should be 0.376 or 0.38, depending on when you round them off. You might lose some precision there if you start rounding numbers off. Okay. So what we're going to do here is I'm going to drop this into our file. Okay. Okay, so we're going to drop that in here. Okay, so that's our solution. That's taking a screenshot of an Excel file, it's dropping it in as a picture. I have a little special software there that does that. Okay. So we basically just took all these inputs, figured out the average, and for every point we subtract the average from it. And with that, we square it. If we go back to our equation, we take that difference or distance, we square it, and we add them all up. So we added them all up here, and we just executed the rest of the equation. We added them up, that's the adding in part. Then we have to divide by n minus 1 and take a square root. So we added them up, we divided by n minus 1, and we got our square root. And that will equal your standard deviation for the sample. Okay, so we got that far. So in 3, if you notice in class, I've been repeating this almost every class for the last 3 classes or 4 classes. In words, define standard deviation. What is it used for? Why would we want to know what the standard deviation of a set of readings is? Okay, so according to one of the solution sets here from Kim, okay, this was quite a textbook response, which is obviously the right way to go, a good way to go. But you know that I've been working with a working definition here. Okay, so in the textbook definition, the standard deviation is used to quantify the amount of variation or dispersion of a set of data values. A low standard deviation means that the data values are close to the mean, and a high standard deviation means that the data values are spread out, and the high and the low here kind of are in reference to each other. You have to have one to look at the other to depend on what defines low, what defines high. Okay. The working definition I want you to be able to walk around and use, because we've been looking at the equation. If you look at what the equation does, I went back through this a number of times. I want to have you have the working definition. The standard deviation is like the average distance of all the points in a data set to the mean. It's like that. You have to remember, we have to put it in this complex form here. It's not a pure form. It's not a pure average distance of the points from the mean. It's done this way because the great mathematicians on whose shoulders we stand now and do great things, the early mathematicians figured out a way that the calculus of statistics works when you define a standard deviation. You know, the standard distance or a standard deviation, a measuring bar of all other points to the average distance to the mean. Okay, that's what the standard is. You measure other points. Now that you have a standard deviation, you can look at new points, but we'll use that in a different way. We'll end up using that to do things like z-scores. Okay, one thing leads to the next. But the working definition, I'd really like to have you have both of these, and make sure you do not forget the word, well, the standard deviation is like. That's the operative word there. As I said, if you look at this, you can tell that it's not the true average of the distances. It's a special form of it that works really well, and the rest of statistics is built on it. Okay, so we're going to look now at question 4. We've done 1, 2, 3. Question 4, z-scores. I gave you a couple of videos to review that help build up some information or understanding here. And the z-score table can be found in Appendix G of the Jacobs book. In words, define the z-score. What I meant by that was, what's the working knowledge or the working definition of a z-score? Okay, what is it used for? Well, a z-score is a multiple of a single standard deviation from the mean. Z-score is a multiple, and that can be greater than 1 or less than 1. Okay, your z-score can be minus. Okay, so z-score is a multiple of the single standard deviation from the mean. In other words, how many standard deviations is my point away from the mean? The units are in the same units of whatever you are measuring. It is the number of standard deviations a value is from the mean. Just repetitious there, okay? It is part of a standardized system to determine probabilities of events happening or not happening. When you refer to the z-score table, you are looking at the cumulative probability of certain conditions happening or not happening. Okay, and this all comes back to the normal distribution curve. Okay, so you need to have the working knowledge. I was asking you this because I've been over it before, and I went over it again today. Okay, so then now we're going to use it. What is the probability in problem 1 of getting a weight reading of antibiotics of 33 grams? So when we go back up here, remember this was all about weight. We had value in grams. Some of these measurements I'm not really, so these are also in grams. This number would be in grams squared, which doesn't make a whole lot of sense. But by the time we sum it and we divide by the n minus 1, when we take the square root, dimensional analysis says it went from grams squared. When you take the square root, you get grams. Okay, so we're back into grams again. So the standard deviation was 0.376 or 0.38. Okay, if you round up to 2 places. Okay, so what we could do here is draw the normal distribution. Okay, give this a whirl here. Okay, so if we draw a normal distribution, it's our x-axis, that's our mean. Draw something like a normal distribution like that, right? It's supposed to be straight and symmetric and everything, okay? So if we come back to what our mean was 33.32 . Okay? Keep pressing the button, it keeps giving that little ring. Okay? And then we have 1 standard deviation, minus 1 standard deviation, and plus 1 standard deviation. And that's, as we know, when we look at the z-scores, the area between those is about 68%. Okay? Okay. So that's just basically a quick look at the data that we're using. We said our standard deviation was 0.38. So what you end up doing would be 33.32. In fact, we'll calculate it right here. Okay, we're going to go ahead and calculate it. So our lower minus 1 standard deviation is going to be the mean. So it's going to be equal to your mean minus your standard deviation, 32.95. I'm going to round up there, okay? 32.95. 32.95 down here. That's minus 1 standard deviation. Now we'll do the other one, which is equal to the mean plus the standard deviation. It should be 33.70. 33.70. Okay, so these are in terms of grams now. These are just in terms of grams. And in fact, our standard deviation was not that much. If you kind of take a look at it and keep in mind 33 point roughly 3 is our average. If you go down here, then look at the differences. It's all what you should see here as these distances from the points to the average should come out looking something around 0.38. Okay, so if you see the range in here, it's about 0.38. Okay. All right, so the z-score converts it into something we can go to the table on. Okay, so the way the z-score works is I gave you the number 33, and there's two answers that are valid for this because the question got asked two different ways, and some people, very few people, came up to me and asked me about that, and yeah, there was an issue with this. I mean, I should pretty much hear from you when you find an issue with a question, but some people actually pushed through and asked me about the way this thing was worded. So quite often, if we look at 33, 33 is going to be somewhere around here. It's 33 even, right? So it's something like right around here. Okay, that's about 33. And the way that the question was asked was, what is the probability that a sample is at least 33 grams? Okay, we're still working in grams here. All right. So what we're going to do is, when we go to the z table, we're going to see that if we want at least 33 grams, that means it's part of this curve all the way over here. Okay, it's from there up. The z-scores give us from the point we're looking at, 33, all the way down. And we happen to know the behavior of the normal distribution is that this probability up here is just going to be 1 minus the probability of whatever we find in our table here. Okay, so we need to look up the z-score for 33 is our point minus the mean, which is 33.2. Okay, so the z-score is going to be equal to 33 minus the average. I'm using all the decimal places there. (33 minus that). Okay, and then we have to divide that by standard deviation. How many standard deviations is 33 away from the mean? Okay, standard deviation is right here, and our number becomes minus 0.86 standard deviations. What are we saying? We're saying 33 is 0.86 standard deviations away from the mean here. Okay, and we want to find the probability. So now I'm going to go to a table that I made for z-scores here. Okay, and we're going to be in a negative part of the table over here. You can make this too. It's not that hard. But more in the negative range, so we're going to go to, let's see if I have it on here, is negative 0.8, and we want 6, so 6 is column T. This is column T right here. So 0.8, 6. We're adding these two numbers together, okay, to get negative 0.86. I've checked the table, it works, okay. So 0.86 is 1949. Okay, so the z-score that we got, here relates to 1949. What are we saying about that? 1949 is there's a 19.49% chance, or 19.5% chance that a reading is going to come up to 33 point. Like this part of the curve, this part of the normal distribution here represents 19.49.5%. And to complete off the question that we had for number 5 was, It was actually asked a little bit in a way that it sounded like it could be interpreted each way. What's the probability of it being up to and including 33 grams a sample, or is it 33 grams or above? And we can get both things. Depends on which way you interpret it or which way you look at it. In fact, you can use information both ways to understand how z-scores work and our statistics here. And what we calculated was that the z-score was a minus 0.86, and when we looked that up in the table, we got 0.1949, which is 19 point, well, let's round it, 19.5% chance that you'll take a sample and it's less than or equal to 33 grams. And if you want to know what the probability of taking a sample and finding out it's 33 grams or more, then all you need to do is, knowing how this works, is take 1 minus that probability, use symmetry here. So it ends up being that obviously they're complementary of each other. One is 19.5% chance below 33, and the other is 80.5% chance above 33. And just to go back to our drawing here, there's our 33. Just to remind us that it was a little bit less than the mean. It was within one standard deviation. It was only 0.86 standard deviations away from the mean. And we used the z-table to calculate here 0.8 plus the 0.6 minus 0.86 is, there's the 19.49. And the reason I've drawn this table is because the one in the book only goes to 4 standard deviations. Okay, so while we're looking at the right hand of my screen here, I have the negative numbers starting with 0, and in the book Appendix G goes to 4 standard deviations, I think, which is right here, and I went beyond that. I went to 7. Okay, and we'll talk about that again. Notice how with rounding, almost all the points up here after a certain point get rounded to 0. Okay, and we can talk about that. After 4, even at about 4, it's rounding it out to 0. That's how small the probabilities are. The tails get very thin pretty much after 3, but around 4, the rounding in Excel has eliminated them. So that's an explanation of the homework. Any other questions, email me or catch me before class or after class. Thanks very much.